Okay, good morning. Um, right. What we're going to look at is engineering mathematics, periodic functions, and periods. Okay, and what I want to look at here first is the amplitude. Now, I was going to put this in a different way, but I think it's important that most of you look at this information for yourselves and read the information for yourselves so that you can comprehend your own style of learning. Okay. So here we're looking at, however, if y equals 4 sine A, each of the values in the table is multiplied by 4, and the maximum value, and thus amplitude is 4. Similarly, if y equals 5 cos 2A, the amplitude is 5, and the period is 360 degrees over 2, which will give you 180 degrees. But I'm not going to want to read these out to you as such. This is more for you to look at for yourselves and begin to apply. Now put pen to paper and write out the questions. Ensure that you've got the right calculations. Okay. And again, we're looking at periodic functions and periods. Let me just make sure I've got that correct. Periodic functions and periods. Okay. Now here's the waveform that which refers to y equals sine 3a. Now somewhere along the lines here I've created a table as well to show you how the table should be created. Okay. And here you have y equals 3 sine 2a. Okay. Now here you can see that here we have 1, 2, 3 waves, 1, 2, 3 cycles, but here we've only got 1, 2 cycles. Okay, 1, 2 cycles roughly there. Yeah. Now here, problem 6 is to ask you to sketch y equals 4 cos 2x from x equals 0 to x equals 360. And here you're looking at the process of doing that, okay? And here we have problem 7, okay? Again, it's just simply showing you the process. Make sure you write these out for yourself so you can understand the concept behind it, okay? And here you have your waveform, okay? And you can see that this relates to this, okay? Now with problem 7, you will see they have multiplied both top and bottom by 5. Having multiplied the bottom by 5, it will simply cancel out, leaving you with 360 times 5 over 3, okay? And I've created a table here, okay? So what I'm going to do now, I'm just going to double click my table. Okay, and I'm showing you here how I have the values of A, okay? Value of 3 times A, and values of sine 3a. Okay, that's what, oh, hang on, sorry, I was just taking notes, sorry. Yeah. Okay. Now for the table you have the values of a, then you multiply the values of a by 3. This is where 3 times a comes into play. You then find the sine of 3 times a, and the values are given in the table. Okay. Now I may be totally wrong, so make sure that you have understood the concept. Do your own groundwork and your own research. Make sure that you have looked at what your lecturer would have said. Okay, I told you, look at engineering mathematics, expand your knowledge. Okay, let me just drop that out. Okay, back to what it was. Okay, and that's the waveform I have here. Okay, now obviously it's not quite exactly like that, but it will do for what I have in mind. Thank you. Okay, periodic functions and periods problem for sketch y equals sine 3 to the a between a equals 0 degrees and a equals 360 degrees. Okay. Lagging and leading angles. Now, lagging and leading angles, a sine or cosine curve may not always start at 0. Okay, and again, here you need to look at this for yourselves and to read that information through. Okay, put pen to paper. Make sure you understand the calculations required. Okay. Now, some of you will be familiar with this, but a little bit of revision doesn't hurt. Now, it is important to remember that pi is equal to 180 degrees. Where pi is divided by 3, the angle becomes 60 degrees. When using your calculator, determine whether you are working in radians or degrees. Here you have amplitude equals 2 and period equals 2 pi over omega in rands. Here, somewhere here, we're showing you how to convert degrees to radians and radians to degrees. Just bear with me, I think it's coming up. Now here, this is just exercises for you to do, okay? Again, exercises relevant here. The sinusoidal form A sine omega t plus. For me, I call it delta. Okay, that's how I remember it. You'll remember it in your own way. Okay, in your own format and style. Okay. Okay, for you to read for yourselves. Okay. F equals 1 over T equal omega over 2 pi in regard to hertz. Okay, so just showing you a different way of calculating. And you have hence angular velocity equals omega equal to pi f right in seconds. Okay. Now, amplitude is the name given to the maximum or peak value of a sine wave, as explained in section previously. The amplitude of the sine wave shown in figure 23.6 has an amplitude of 1. Okay. And here we are showing you the relationship between radians and degrees. Here we're looking at converting radians to degrees and degrees to radians. So we know that 360 equals 2 pi radians, or 180 degrees equals pi radians. Hence 1 rad equals 180 over pi equals 57.30. And for example, we want to convert 71 degrees to rads. Then here we multiply 71 times pi divided by 180. Now will that work? Let's just have a look. Will that work? And 1 times 71 times 3.142 equals divided by 180 equals exactly smack on actually. Okay, remember that for engineering we use pi as 3.142 as pi is infinite. Okay, the above gives you information in respect of converting degrees to radians and radians to degrees, where 1 rad equals 180 degrees over pi equals 57.30 degrees. In this case, remember that pi is equal to 3.142 in its simplified form. To convert degrees to radians, for example 71 degrees, we follow this process. Okay. Okay, and again here we're simply looking at information that you can apply for yourselves. Some of you should be familiar with this stuff overall by now, okay? But it's still important to have it available and to show a different perspective on it. You know, I don't know what happened here. It just went all peculiar on me. If it doesn't come out right, I'm going to look at it when I run it through the editor, and I'll decide whether or not to keep it or delete it. We're looking at instantaneous values, okay? Sorry, that we're looking at that there, so you need to be able to see that. Okay. Can I get it in? Okay, yes, I think I got it. Yeah, I think I got it. Yeah. Hopefully I have. Okay, again, this is just working out. Again, apply the principles and calculations to find the correct answer. Okay. Okay. Thank you. I hope you found this useful. Let me just make sure. Let me just take it back. Recap backwards. Okay. Bear with me while I go back to the top, very top. Make sure I've got it all on screen, on camera. Okay. I think I took this in HD actually, because I have a feeling that HD is going to be the norm pretty soon. A bit peculiar. Okay. Coming to close of it now, I believe. And thank you for your time, and I hope you found this useful. Okay. Have a good day. Bye bye.